Good day, learners. Welcome to today's Natural Sciences Virtual Learning Recovery lesson. The lesson is on series circuits. My surname is Botha and I will be responsible for today's lesson. So today we will be looking at series circuits and what the influence is of increasing the number of cells in series on the overall current in a series circuit. Before we look at that, let us quickly revise our series circuit. Here we've got a simple series circuit diagram with one cell. Here we can see the cell. We know inside the cell we've got chemical energy which is converted to electrical energy. That electrical energy is moving through the conducting wire. Of course, the switch here should be closed. If the switch is not closed, then the current is not able to flow through the electrical wire or the conducting wire, right? Then the current passes through this, which we call an ammeter. The ammeter determines the rate at which the charges are moving, or the number of charges which is moving through the series circuit per second. Then the charges carrying that energy, electrical energy, reaches this first bulb, where that electrical energy is converted to light energy. From there, the current continues to move through the wire, and then it reaches the second bulb, and inside here also electrical energy is converted to light energy, and then afterwards the charges is moving back towards the cell. It's important to note when the charges are moving here towards the cell there, it doesn't contain any energy or electrical energy anymore. But when it reaches the cell recharges or gives the charges new electrical energy, and then the whole process is actually repeated. Now we can also look at a simulation. Here we've got a simulation, and you can see I've got a switch. The moment we close the switch, let us see what's happening. We can see here is the cell. Charges are moving. You can see the charges, and the charges are carrying energy. Then the charges are moving through the ammeter. This apparatus here is an ammeter, and it's got a reading. The reading says 1 ampere, meaning that 1 coulomb of charges is passing through this ammeter every second. Then the charges continue. It goes through the bulb here, and in the bulb we can see there's an energy conversion, and these orange lines here shows us the light energy. So the energy conversion inside the bulb is from electrical energy to light energy. Then the charges keep on moving, and it's important to see that the charges move at the same rate. So if you compare the charges on this side of the bulb and on that side of the bulb, meaning there and there, the charges are moving at exactly the same rate. The only difference is the charges over here has got less energy, because some of the energy was already converted in the first bulb to light energy. Then reaching the second bulb, the charges again, there's energy conversion from electrical energy to light energy, and then the charges keep on moving back to the cell, and it reaches the cell here where energy is given to the charges, and the whole process keeps on. Now what I'm going to do now is I'm going to open the switch and add another cell. You can see there's another cell coming in, and now when I close the switch, we must notice what happened to the ammeter reading. Now you can see the ammeter reading is 2 ampere, double as high. And when you look at the charges, you can see the charges are really moving fast now. So the ammeter reading tells us that more charges are moving through the circuit per second, and because of that, a lot more energy is able to convert from electrical energy to light energy every second, for the mere fact that the charges are moving faster, right? Even in the second bulb we can see it's the same thing, and then the charges go back to the battery. Now it's made up of 2 cells, where chemical energy is utilized to give us more electrical energy, which moves. I'm going to open the switch, put in an additional cell, and see what happens now. Right, now we can see the charges are really moving fast. Looking at the ammeter tells us there's it's got a reading of 3 ampere. So there's 3 coulombs of charges moving through the circuit every second. And there's quite a lot of light energy coming off in each one of the 2 bulbs. So in general, what can we say? The more cells that we connect in a series circuit, and connecting those cells in series, the higher the current will be, meaning that more coulombs of charges will pass through the circuit per second. And we could see that on the ammeter reading. It started off with 1 ampere for 1 cell, 2 ampere when there was 2 cells, and then finally 3 ampere when we had 3 cells. Learners, in summary, we can therefore say that the more cells connected in series, the stronger or the higher the current will become. You will remember from the circuit that you saw, when we had 1 cell, you can see 1 cell here, the ammeter reading had a reading of 1 ampere, saying there was 1 coulomb of charges moving through the circuit. Then, with 2 cells in series, the ammeter reading was 2 ampere, there was an increase. And then with 3 cells in series, we could see that the ammeter reading was 3 ampere, even a higher current. And that confirms our summary, that the more cells connected in series, very important in series, the stronger or the higher the current will become. Finally, learners, we want to compare the ammeter readings, or the size or the magnitude of the current at different places in the series circuit. Now, when we look at the series circuit, we can see there's 1 cell, the switch is closed, there we can see it. We've got 2 bulbs in series, and we've got 3 ammeters in different places. Here's an ammeter here, there's another ammeter, and there's another ammeter. Moving over to the simulation, this is exactly the same picture. There's 1 cell, we've got an open switch, there's 1 ammeter, a bulb, another ammeter, a bulb, another ammeter. I'm going to close the switch. Closing the switch, we can see the current is flowing. And now when we compare the ammeter readings, we can see, yes, 1 ampere, this one is 1 ampere, there's another 1 ampere, 1 ampere. So we can see the ammeter reading in all the different places in the series circuit is exactly the same. And the reason for that is that the current is flowing at the same rate, or we can say at the same speed, at all places in the series circuit. We know that the charges are carrying energy and losing energy or giving energy off in the bulbs, but the speed at which the charges are moving through the series circuit is the same everywhere. I'm going to put in another cell so that we can see what that influence will be. Right, opening here. I'm bringing in another cell. There's another cell, closing. Now we can see the current is moving faster. It's 2 ampere when you look here at the ammeter reading. This ammeter reading also 2 ampere. That ammeter, it's also 2 ampere. So at all the different positions in the series circuit, the ammeter reading will be the same irrespective of the number of cells. You can increase the number of cells, but the ammeter reading will still be the same everywhere. Thank you, learners.